Well, it's time for our recap of today, Friday, and for honors physics. So it is Friday finally, and after this we have spring break for a week, and then I don't know. So as of right now, nothing has changed. We are still scheduled to go back after spring break, and although that's like right now. So anything can change in an hour or in a day or three. It doesn't, I don't know. Nobody knows. I do expect that we'll probably be gone a little bit longer. I don't know though. So, but in any case, we do have next week off. So hopefully you get to use it. I know we don't get to go anywhere, but at least you don't have to worry about school anymore. So, hey, Angelina, how are you? It's weird not seeing everybody. I'm actually considering doing like a thing where, well, I'll talk about that later. There's an option in Microsoft Teams where if you wanted to, we could all see each other and kind of talk instead of typing stuff. Minecraft when? There was a brief moment in yesterday's, or maybe 2 days ago, when I played for like 5 seconds. But yeah, I don't know, Angelina. I don't know. I've been kind of like, yeah, we got to do physics, and that's been kind of wrecking me to do physics, and then like doing live stream. Anything else is like kind of like I don't feel like I have energy. But so question mark is your answer. I don't know. Maybe eventually. So I'll look into it though. I know I keep saying that, but I don't know. So, let's see though. I did meet with other physics teachers, honors physics teachers this morning, and we did use the Microsoft Teams. Hey, Aiden, what's up? So we did use the Microsoft Teams, and that was kind of nice because it was It was good to see other people's faces and talk to them. Like we all just like, if you've got Teams on your computer, I think. So what I might end up doing is just for the fun of it, maybe in a couple days or whatever, or break, I don't know. But I might try that out instead of this format, or maybe in addition to this format, because this is great for me showing you stuff. But I mean, you guys have to type in to say stuff, which is great. But maybe we could actually talk to each other if you're up for that. Won't be anything required, and I'll probably still keep doing this and using the remind and all that. But like I said, it's nice to see each other's faces and actually hear each other's voices sometimes. So things going on, things I'm thinking of, especially if we have to do this much longer. So if they declare that we are going to be out for much longer, then I'll almost definitely do something like that. So, but we just wanted to get through this week for now, and we've almost done that. So right now, there hasn't been any quizzes or anything like that, but you have, yeah, good. Okay. That's what I thought. And because I've been playing around with the Teams, looking into it. So, I thought you guys had it because I feel like it's kind of built in, to it. So basically what I would do is, yeah, like I said, it's good to see each other's faces. So I'm kind of clicking on it right now, all Teams. So basically I would do something like this. I kind of already have it set up. But I don't think I'll be doing anything through it at this point. It would be more just to, you could like do meetups and stuff like that. I know you could do it through Google Classroom too, but I liked the Teams better for different reasons. I don't know though. Just something I'm playing around with, one of the options that we have. So, alrighty. So if you're keeping on schedule, first of all, if you haven't been keeping on schedule, that's fine this week. But I say that because if you still have 3 o'clock, huh? Yeah, that sounds about right. Aiden, yeah, so Governor Pritzker has been getting on about 2:30 every day, roughly, 2:30, 3 o'clock. And that's kind of what I'm expecting it to. So if you are... if you're watching this and you want to hear that live, watch it live. You could either watch the news or I've seen it on different social medias and radio and stuff like that, where you could listen to Governor Pritzker talk about what the plan is. So yesterday yesterday, I should say that the mayor of Chicago, if you don't know this, the mayor of Chicago declared that Chicago public schools will be not coming back until like April 20th. They are a separate thing though. They kind of do their own thing, but most people took that as a sign that the rest of the state will be following their lead on that. So yeah, just that's something I'll be expecting too. So by the way, if you ever see me like glancing over there, it's because that's where my second monitor is at, and that's where like whoop, 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 I could like got everything going. So but we'll see. We don't know. But anyway, what I was saying is if you have not been keeping up with this and you're still like what if you're on assignment 2? Don't feel bad about asking me a question. Even if you don't do it on the live stream, you could definitely do it on the Remind app or even via email. Okay, people have been doing both. So if you need me to explain something, and I haven't had to make any extra videos, but I can and I will if I need to. So since I don't get to like walk around the classroom and help you out individually, then well, we'll see what we can do. Okay, so that will actually be kind of a nice thing about the teams is I could say, well, go ahead and jump on the teams and then we could talk it through or something. I don't know. Again, we'll play this by ear as things go on. But anyway, don't feel bad about asking me questions about past things, especially this week. But today you were scheduled to watch the video on resistance and solving for resistance. And then there was these things, and hopefully you got the printout. If you didn't get the paper version of this, then you've been doing this on the screen. And even if you got the paper version, you could still be doing this on the screen. And either way is fine for me. But so I want to know if you have any practice on solving for resistance. So this was the first side, and then this was the back side. And the back side is much more challenging than the front side. But even the front side can be challenging. Well, maybe not these first 6. Literally, you just add them together. That's how you do a series circuit. And then these other ones, you had to do the, how do I say it? The inverse of the sum. The backside was confusing. Yeah. Is there anything you want me to do, Angeline, any one of these? They're not numbered, but I mean, we could go 1, 2, 3, 4, 5, 6, 7, 8, I suppose. But is there anyone you'd like me to start with or do? Because I will gladly do it. Uh-oh, I lost you. There we go. Let's take pictures of each practice and then put it on the go. Yeah, Aiden, that's the best I could come up with. There is just going to be, what do you call it? Formative, first and second one. Okay, cool. Yeah, it's going to be formative grades. So I will leave it blank if you don't do it, and that's fine. These are extenuating circumstances, and don't even worry about it. Hopefully you are doing it. But if you would like some points for it, I can give them to you. All right. Eventually, if we do continue to be out, I'm going to have to quiz you and eventually test you on this stuff. So, yeah. So hopefully you're doing this. First and the second one. All right. Can I do these both in one? Is that 10? No, 10 doesn't go with this one. I don't think. Okay. Well. Did I just take a picture of that? No, I did not. I just highlighted everything. Cool, good, yeah. All right, this is what I wanted to do, is the little Control S. Oh, Mr. Jern. All right, Windows, Shift S. There we go. All right, now I should be able to just take a little snapshot of that. And I'll pop it into a, what do you call it? This thing, PowerPoint. And good. Let me just change the pen color again because, I don't like it. The default is red. Purple's fine. Cool. So how do we do this? Well, all right. So basically, these two are pretty similar, and that's okay. But if you look at the overall for this one, you can see it looks kind of like a series circuit, but nestled in that little series circuit is a parallel circuit, a parallel. These two resistors are wired in parallel. And so, like I kind of hinted at yesterday, is you want to take it like from the inside out, work from the inside out. So I might be good if I do another one. These are both kind of like have a parallel part nestled inside of a series. And there's other examples where you have a parallel series nestled within a parallel. So just, if there's another one that looks like that, I could do that. But let's see. So what we want to do here is with a series circuit, you just add up the resistors. So the 5 and the 0.25 are going to be easy to add together. You get 5.25. But then there's this mess right here, which is the parallel part. And the parallel part is where you have to take the inverse of the sum of the inverses. All right. So what I mean by that is I have to do 1 over 1 plus 1 over 3. Okay. Because 1 over 1 and 1 over 3. And the way I put that in my calculator is the easiest way, I think, is to, let me just see if I can focus this. See, I anticipated, I got my little document camera out. Okay, that's better. So 1 over 1, I mean 1 over 1 is pretty straightforward, but just to kind of, so here, I could go, but I use parentheses. So 1 divided by 1 plus 1 divided by 3 is what I want. I get 1.33. Or I like this on mine, it is right here, this little x to the negative 1 button. That's the inverse key. So what I'm going to do is I'm going to do 1 inverse plus 3 inverse, and I get the same answer because that inverse key, this little thing right here, could use a black pen to point out here. I'll use a white pen to point this out. This little key right here is sort of like 1 over this, right? And it's super helpful. So it's almost as helpful as that E. So anyway, that is the answer to this one. Where'd my pen go? Pen, come back. Seriously, where'd you go? Well, that's weird. Click. What'd I get? 1.33333333. Okay, so 1.33333333. Repeating, of course. All right, but then I got to take the inverse of that. So I could take 1 over that is equal to, or I could just do on my document camera, or on my calculator, confusing all my things. All I got to do is hit the inverse button again, this little thingy, and it will automatically take the inverse of the answer. So I know now the answer, the total answer is 0.75. So let me get rid of that. And so now I know that this is 0.75, which means that this whole section right here is 0.75 ohms. Okay, so that's the equivalent. So basically now I have a 5 ohm resistor. Why only the 1 and the 3? Why only the 1 and the 3? Because those are the two that are in parallel with each other. Okay, the other ones are all in series. So series is one after the next. So if you look at it overall, they're one after the next. It goes 5, and then it goes this parallel part, and then it goes this next part. So this is the series, but then you branch off here and in parallel with each other. But then it comes back together, and it acts like a series circuit again. So the 1 and the 3, because they're in parallel with each other. All right. So I don't know if that helps, but so then now that the 1 and the 3 are together, because they're in parallel, the equivalent resistance is this 0.75 ohms for this part right there. And so I could take the 5 ohms from the top one, and then the equivalent of 0.75 ohms from that side one, and then add it to the 0.25 ohms of the bottom one, and that gives me an answer of a total of 6 ohms. And that is going to be the, man, I can't draw, but that is going to be the total resistance of this entire thing. So 6 ohms. All right. So to do this one, it's going to be very, very similar. I have a 6 ohm resistor in series with a 7 ohm resistor, series because there's no branches in between them. They go one after the next. And the 6 and the 7 are in series with this big parallel part right here. Well, it's not a big one, but it's this parallel part right here. So this parallel part is in series with the battery and these 2 resistors. And so this is a series circuit, but this part inside the purple circle is in parallel with each other. And so just like with the other one, I have to do 1/4 plus 1/4, and it's going to give me 2/4. Okay, so I could do this without the calculator, I guess. And if I take the inverse of that, then that gives me 4/2, which is 2 ohms of resistance. Okay, so to show you that in the calculator though, because you know what, let's just get used to using that. I'm going to clear that out. So it was 4 inverse plus 4 inverse gives me that. And then I take the inverse of the answer and I get my 2. Okay, so the calculator is kind of nice because you could see like the calculator does the same thing for a more like doable question. It does the same thing that we just saw. So 4 inverse plus 4 inverse gives you 0.5. Take the inverse of that answer and it gives you 2, which is exactly what I got right here. Okay, that means that this circle part, where's my pen? Come back, pen. Click. There it is. So my circle part here is this whole thing is where, well, all right. I clicked a button on my pen. Sheesh. Click. Stop. All right. I don't want to leave. Let's come back to that. There we go. Can we draw again, please? Sir, ma'am. I'm asking nicely. Okay, good. So anyway, this whole parallel part is an equivalent of 2 ohms of resistance. And so now we can take our 6 ohms plus our 7 ohms plus our 2 ohms equivalent. And that gives us what? 8 plus 7, 15 ohms. So the total for this particular circuit is 15 ohms. All right. Yeah, Jaime. We're gonna do. We'll do something like. Well, maybe do something like this. It's not that tough when you get used to it, though. I mean, it's just new, so everybody's getting used to it. And hello to you too, sir. So that is that. Let me do one that's. Let's do another one. Let's do this one right here, the next one down. Yeah, good. I'm glad. Let's do this middle one right here. How about? All right, because this kind of like is a little bit of everything. I think I got it. So this middle one. All right. So let me make a new little slide, pop that in there. Yeah, make it big so we can see it really well. And doomph. All right. So let's do that middle one. You too, Jaime. Thanks for stopping in. Let me know if you need anything that I could do anything for. So, and happy spring break if I don't see you. All right. So this one is, well, a little bit more complicated. This one, look at this. We got the overall thing is a series circuit, but within that we have parallel, but within that we have a little series part right here. So it's a series within a parallel within a series. And it gets confusing, but just work your way from the inside out. Like we can't add the 10 in any of these things. So we know that we're going to have to do something here. And you should know that we can't do 1/5 plus, I mean, these two are next to each other. There's no choice. This is a parallel part right here. Sorry, a series part right here. So right away, I mean, with a series circuit, what do you do with the resistors? Well, you add them together straight up. So these two together end up being 5 ohms, meaning the 4 and the 1 have an equivalent of 5 ohms. So this branch right here is a 5 ohm resistor equivalent, okay? And now when taken together with this other branch, which is also 5 ohms, now we can do our little trick of well, now it becomes like the other ones, the ones I just showed you. So we could do 1 over 5 plus 1 over 5 gives us 2 fifths, which is, well, I'll just write it out like that, 5 2/5. And if I take the inverse of that, that gives us 5 over 2. So what is 5 divided by 2? So that is, what, 2.5? Okay, ohms of resistance for that little part. I'm going to do a little cloud thing. Let's double check it with the calculator. So we had a 5 and a 5 ohm resistor. So 5 inverse plus 5 inverse gives us 0.4. We take the inverse of that, and there's our 2.5. So good. So just use the calculator if you're not sure. I don't really mind. You know, hopefully you brought your calculator home, or you have one you can use. And where'd my pen go again? Oh, we're going to play this game. Come here, pen. There we go. Yay. All right, cool. I'll just make a little, yeah. All right, cool. So now we know that the equivalent of all this is 2.5 ohms for all that. And so now we've got our 10 ohm resistor, and then that's in series with that 2.5 ohm resistance area, and then that's all there is. So our total is going to be 10 ohms plus the 2.5 ohms of the equivalent there. So the total answer is going to be 12.5 ohms of resistance for this whole thing. Okay, that's it. Not that's it, but that's how you do these things. So anything else? Anything else? Start to see what I mean by work your way from the inside out. Okay. Keep. Just in case. All right. Well, let me know. And hope you guys are doing well. Like I said, there's a lot of unknowns, a lot of uncertainty. And when it's at the forefront like this, sometimes it's hard. But it is temporary. We will get through it. Next week, spring break. What does it mean, lab report, when asked to rewrite the equation from the graph in terms of V? Good question. So in order to do that, so let me just pull that up. So in terms of V and I and R, so if it's the one I'm thinking of, Maria, basically let me just put this back up because it's going to be easier if I have something to draw on. Get my little writing pad again. If I remember correctly, you made a graph, and it's not writing. Let me click on it. That's wonderful. All right, try that one more time. Maybe I had to click draw down here. All right, let's not draw. Let's do this dark blue again. All right, now I can't see you guys. Okay, am I back? Am I able to draw? It sure looks like I could draw. Yay! All right, cool. It's a cool little swirly I made. All right. So you had to make a graph where that's perfect. On the y-axis was voltage, I believe. Okay. On the x-axis was current in amps. So you had to divide. So okay. So current in volts. And then you should have a graph or a slope like that. It is a straight line, I believe. And one thing that I would have mentioned more in class if we had had the time is what you'll notice is the slope is just going to be delta V divided by delta I. And hopefully you just did the line equation. You got a y equals mx plus b. So you don't even necessarily need to worry about slope. But that's slope right there, right? So what it means by putting the line equation in terms of V and I and R is, okay, what's the Y? Well, the Y is going to be volts, is equal to, well, M and X was I, and B was, well, it should be 0 or close to it, some really tiny number, I would hope, okay, depending on how good things were. So it can be really close to 0, so we could pretty much eliminate that. And now the thing we got to keep in mind is if you look at the slope should be really close to the resistor number. All right. And so if we were to really, really write this in terms of that, knowing that the slope is the resistor number, and again, this is not something I was able to talk about too much, then we could say V is equal to, instead of saying the slope, we could say the resistor times the current, okay? And then plus 0. So, and that obviously looks very, 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 very similar to V equals I times R, which is the Ohm's law thing that we talked about before. That's where we got that's where we get Ohm's law. Is, you know, scientists back in the day did all these tests, and probably, you know, Ohm himself did a lot of these tests, and he found that the resistance is related to current and voltage in this way. So anyway, Maria, that's what I mean by that. You might actually have a number instead of R, and that's okay. So you're going to have like the voltage is whatever the number is. Like, I don't know, maybe you had like the 110 ohm resistor times current, and that's fine too, okay? So that's what I mean by that, Maria. So this is the more general version of that, and this is like probably specific to whatever resistor that you used. All right. Anything else? Well, if not, you know where to find me. Remind. If and when they send out an email about, or if we get a notification about school being closed longer, then I'll probably set up the teams, and we might be able to do some face-to-face. I'll still do this. You're welcome, Maria. Anytime, of course. I'll still do this because I think this is probably easier for me to show it, and not everybody's going to be comfortable getting on Teams and using your voice to ask questions. Angelina, I played about an hour of Animal Crossing last night when I couldn't sleep because, believe it or not, I have, you know, I just woke up and yeah, sometimes, you know, with all this unknown stuff, I couldn't sleep. So I grabbed my Switch and yes, I played it. It was pretty fun, but yeah, I didn't get a long time with it yet. I'm planning on playing very soon, actually. So all this morning and up till now, I've been working on school stuff, and I get, you know, sometimes you gotta be like, all right, I gotta get my work done, and then I can play. But yeah, it's been fun. I'm looking forward to it. Actually, I'm gonna go on a little bit. My daughter's gonna go play, and we're gonna play together, and I'm gonna watch. And I don't know, we might be able to do 2 players. I don't know. We're gonna find out. There's a lot of things I don't know about it, but it's pretty cool. Have you played it? That's the real question. Has anybody else played it? Hey. Do. No. All right. Coruscant, nice. Yeah, I named mine Tarak Nor, and I'm kind of regretting that. So we're probably gonna end up deleting Tarak Nor and your island. Yeah. So the annoying thing is I did all this, you know, the introductory stuff, and I'm gonna have to do it all over again now. But that's okay. Coruscant is a good one though. As long as you don't name it Corona, that's fine. Like Entangled, then we're good. I got, oh boy, who did I get? And they're, like I said, they're gonna get deleted. I got the horse, Buck, and I got the sheep, the one who keeps calling me some kind of poison, nightshade. I didn't realize there were different ones. Look at all this stuff. So anyway, yeah, like I said, it was the middle of the night, and I don't remember what villager I got besides Buck. She didn't seem very talkative. Although it was the middle of the night, and she was out there in the middle of the night. So Buck was sleeping. That was a weird thing about this game, is like it's in real time. Super. I'm looking forward to it. All right, speaking of which, I hope you guys get your work done, get everything done. Take a break next week. If you haven't, take a break from school. Take a break from all this. I know we can't go anywhere, but read, play video games, go outside if you can. Stay away from people. Build something, make something, I don't know, draw something, sing something, write something, but do something different than school for a little while and try to get your mind off of the worries of the world. And if you do have questions, let me know. So, all right. Well, you guys have a wonderful weekend, a wonderful spring break. Let me know if you got questions. Just hit me up on the remind, and I will see you when I see you.